So what are you guys?
We are the SWARTWOOD family.
So are you guys real SWARTWOOD MCAT students?
Hell yeah!
So what happened is you get drunk, you give them the chance to hook up, they don't hook up. They go like, we shouldn't go there, we're friends. Now they're in this protected spot because the boyfriend knows he's a creeper. So he's like, dude, that guy's just no. But then you're like, he's the one that told me to go back to you. Are you like jealous? So now he's in this protected spot and he stays in that protected spot. We're all looking at her like, what the hell are you doing? And she actually sitting there going, he doesn't think I'm stupid. You just told me that. Obviously he really wants to study. And while she's talking, he's just looking over her shoulder at me going, it's all good. So let's clean the slate. We did all that crud. We're done with that junk. Let's start fresh. So I know probabilities, number of ways of getting what you want over total number of possibilities. Now we have something called conditional. Okay. And certainly like you've done conditional probability, right? Mm-hmm. Okay. So first I want to get used to this notation. So it's like this. What's the probability A given B? It doesn't necessarily have to have a time element, but it's just easy to talk about it that way. So saying, what are the odds that A is going to happen when you already know B has happened? Okay. Good, huh?
Would it be the same odds that A would have happened, like regardless?
Oh, that would be good if they're independent, but they're not independent. So we don't know yet. They might be connected, right? So let's do this just general form. Did he make you do this stupid formula? Yeah. Okay. I mean, it's kind of like this guy is that guy. You kind of denominators look the same, right? But since this is easy for us to see, let's just do this. I'm going to do a little fake, but this is not that far off from the formalism. So here's your event A. Okay. Probability is what you want over total number of possibilities. So it's just like the area of A. But now I'm changing the game. I'm saying I want to know what's the probability you land in A somewhere given that you're already in B. So if you're stuck in B, where's the only place you can end up in A? Because that's what you want, to end up in A. This intersection. Do you guys agree? You don't have all the possibilities anymore, just this stupid intersection. So probability is always what you want over total number of possibilities. So this is analogous. What you want is to be in the intersection, this guy. What are the total number of possibilities? It's not the whole universe anymore, because I already told you you're stuck where? In B, so you should be stuck in B. So it's what you want over the total, same idea. Okay. Okay, so are we okay with this? Okay, before we go to break, I want to do a baby problem with this, but I kind of want to do the high school way. There are two ways to do it. One way is the high school way doesn't mean it's easy, it just means it makes more sense. So there are problems where you just do this formally. You look at the probability of intersection by itself, you look at the probability of B by itself, you do the math, you get the answer. But on small counting problems, maybe you don't want to do it that way. Okay, so let's do one version of this. Let's do a really easy one before we go to break. You roll a 6-sided die. Okay. I want you to tell me what is the probability you get a 1. It's cheesy, but it's okay. Given that you know the number you roll is odd. Okay. So let's do both. Let's do this formalism. So the formal way is what? You want the probability that you are a 1 and you are what? Odd. I mean, you can make that the intersection symbol. Same thing. Okay. Over the probability that you are odd. If you want to use this formula, you can't assume this has happened. You got to just literally start from scratch. So do each piece by itself. But usually there's reduction. How can you be 1 and simultaneously odd? I think it's redundant. You could just be 1 because 1 is odd. Do you guys agree? So that's what you're really computing. But I do purely from scratch. So you don't know anything. What are the total number of possibilities? 6. How many of them give you a 1? 1. That's the top guy. You guys start purely from scratch. Now do the bottom without knowing that junk. There are 6 possibilities out there. How many of them give you an odd guy? 3. Right? So then when I do the formalism, it's 1/6 divided by whatever, 3/6, so that's multiplying by 6/3. So it's 1/3. Okay? Then we could do the high school version of this. I mean, in all finite cases, the total number of possibilities is always going to be the same, right? So it's always going to cancel out, right? I mean, even non-finite, whatever. So it's going to look like that. So the high school way is this, which I think is actually better. Here are 6 possibilities, right? So the high school way is this. This has already happened. So just cut what's impossible. Can't be a 2, can't be a 4, can't be a 6. That's it. Now you just do regular math. What's the probability of getting a 1? It's one choice out of how many? 3. So we're done. Okay. Most small problems, this is way faster, way more efficient. But in problems where it's really wordy and they're talking about clubs and full houses and you're getting very confused, this might be easier. Okay. Okay. So do you want to take a break now then? Yeah? Or do you, good? Okay. So let's take a break and we'll come back and do a couple more problems on this and then we'll go to like the other stuff. Sum rule.
So for today's lesson, we're going to be talking about counting. So counting is kind of a continuation of what we're talking about with sets. Just a quick review about sets. When we're talking about sets, the two things we're going to be looking at is something like this, which is set A or B, or something like this, which is set A and B. So everything in set A and that is found in both set A and B. So there's a continuation of that is counting. And so counting is essentially counting all of the ways something can be done. So let's talk about the first principle of counting. It's called the addition principle. And basically the addition principle says that when you have a number of events where you're looking at something happening or another thing happening, so an event or another event happening, you can add them together. So it's kind of what you would expect when we're talking about the addition principle. And so one of the keys with knowing you're dealing with the addition principle is the word or. So essentially the addition principle is something that we've already really looked at, which is, if you remember the inclusion-exclusion principle, it says that A union B is equal to A plus B minus the intersection of A and B. But one of the key things about addition principle is the events you're looking at have to be disjoint, meaning that they don't overlap. And so because they're disjoint, meaning there's no intersection, the addition principle deals with this. You're going to take out the intersection, and you're only going to look at each individual event. And because you're looking at each individual event, you can just add them all together. So that might be a little technical, so we'll look at a quick example. Let's say that you're choosing between a couple dinner places.